Here are your objectives for 1.6. Solve polynomial equations by factoring. Solve radical equations. Solve equations with rational exponents. Solve equations that are in quadratic in form. Solve equations involving absolute value. And solve problems modeled by equations. So this is a lot in one section of the book. Okay? In Algebra 2, most of these were in completely different chapters. We did radical equations in one chapter. We did rational equations in one chapter. Rational exponents in one chapter. We did quadratics in one chapter. Absolute value in a different chapter. So hopefully you see that we are solving equations, right? It's just what kind of problems are in the equation that you have to deal with to figure out how to solve them. Okay? So let's do a couple of examples. So let's start off with factoring, okay? Now we did factoring in the last section, so hopefully I'm not going to have to do a lot of teaching about how to factor, but just show you with the problems factoring examples, okay? So let's say 2x to the 5th plus 10x to the 4th equals 0. If that's the equation, what do we typically want to try anytime we're factoring? First. So we want the greatest common factor out first, right? So in this particular problem, what's the greatest common factor? 2x to the 4th, right? 2x to the 4th is the greatest common factor. If I divide that out of this term, what do I have left? X. And if I divide that out of this term, what do I have left? 5 equals 0. If I have two things multiplied together and they equal 0, it has to be true about at least one of them. 1/2 equals 0. So I set both of them equal to 0. Just to cover all my bases. And then I just solve them. If 2 times x to the 4th equals 0, x is going to equal 0. If x minus 5 equals 0, then x equals -5. Now, fundamental theorem of algebra says that whatever my highest exponent is, that's how many answers I should get at the most, right? Well, I only got 2 and I should have gotten 5. But if you think of this right here, x to the 4th, that really takes care of where 4 of the answers are, right? So basically 4 times the answer is 0. So I do have my 5 answers, at least covered. Okay? Does that make sense? All right. Ready for another? What about if we have x to the 3rd plus x squared plus 5x plus 5 equals 0? When there's 4 terms, what are we going to try first? Okay, so we always want to try greatest common factor first, right? So look on all 4 terms. Is there something that all 4 terms are evenly divisible by? No. Okay, so now if there's 4 terms, we should factor by grouping. Exactly. Okay, so we're going to look just at the first 2 terms and then separately just at the second 2 terms. So if I look at the first 2 terms, just the first 2 terms, what do these 2 terms have in common? What's their greatest common factor? X squared. And what's left if I divide this term by x squared? God bless you. So x plus 1. Because this term by x squared is x. This term divided by x squared is 1. What about in the second 2? What's common in just the second 2 terms? So 5. If I factor out a 5 from each term, what do I have left? Now remember, when we're factoring by grouping, we want this parentheses to be the same, because what we're going to do next is we're going to look at this term and say what is its common factor. What do both of these terms have in common? They have an x plus 1 in common. If I factor it out, what's left?
X squared plus 5.
Perfect. X squared plus 5. Again, 2 things multiply together to equal 0. So at least one of them. So I set both of them equal to 0 just to cover my bases, right? So here, excuse me, I'll get x equals -1. And here, I get x squared equals -5. How do I solve x squared? Square root. So x equals, you put the root sign in there, so you have to put the plus or minus. That's exactly right. Do you know the square root of 5? Do you know the square root of -1? So I root 5. Now how many answers should we have gotten? 3. 1, 2, 3. Done. One's the plus and one's the minus. What's wrong? What do you mean neither of them equals 0? If you put that in here? Okay. You're not. You're not stupid. Quite far from it, in fact. Okay, so far? How do you feel about solving polynomial equations by factoring? Yes? Okay. So now let's look at some radical equations. Okay. What do I not mean by radical equations? Politicians? I don't mean that kind of radical. That was just a little math joke. Okay, sorry. It wasn't very funny. That's all right. I accept that. So what if we say the square root of 2x minus 1 plus 2 equals x? What if that's the equation we're trying to solve? What should we do first? Because we want to isolate the radical, right? So if I isolate the radical, I'm going to subtract 2 from both sides. And I would get the square root of 2x minus 1 equals x minus 2. How do I get rid of the square root? How do I undo a square? Excuse me. How do I undo a square root? I was saying the answer. Good. So square this side, right? The whole side. Okay, so what do I get if I square a square root of something? I just get the something, right? So I have 2x minus 1. What do I get on the right-hand side? That's what I was afraid you would say. What does it mean for something to be squared? So x minus 2 times x minus 2, which I have to now distribute, right? So if I distribute, I get x squared. Time again. Yes. Okay. Minus 2x. I'm okay with that. Let me do every step so if you're not with me, you can see where at least I'm coming from. Minus 2x and then plus 4, right? Then I have to combine my like terms. X squared minus 4x plus 4. So on the right-hand side, we have x squared minus 4x plus 4. You okay with that? Now what? Why? Why do you have to combine like terms though? You want it equal to 0? It would be. Absolutely. There is an x squared term, but there's also an x term. And if there's both of those, we know some ways to solve those, factoring being one of them, right? And so, but the only way we can solve it by factoring is to get it equal to 0. So subtract 2x from both sides and add 1 to both sides. So 0 is going to equal x squared minus 6x plus 5. We could factor, we could quadratic formula, we could graph it and see where it crosses the x-axis, right? Any of those things we could do. What do you choose? Factoring, okay. What multiplies to be 5 and adds to be negative 6? Negative 5 and negative 1. Now what? Perfect. Set them equal to 0. X equals 5. X equals 1. But we have to be careful.
Yeah, I did not know this.
You have to. Why do we have to be careful?
Because they don't always.
Yeah, we didn't worry about it back here, right? We didn't check back here, or maybe you didn't, but I did because I just thought about it in my head, and instead of saying it out loud, which is what I should have done because I'm the teacher, right? If I put in 0, that's 0 plus 0 equals 0. If I put in negative 5, that's a little bit harder to do, but it's still going to give me 0, isn't it? Okay. We even talked about negative 1, plugging it in, and we figured out it was 0. These are, again, a little harder to do, but can be done, and it does equal 0, right? Why do we have to care so much on this one? Because of the radical. Okay? Because of the radical, we have to care. Because we took the radical, a squared function that looks like, the parent function looks like this, right? That's what the parent function of a square root looks like, right? Okay, and we made it into a quadratic where the parent function looks like this. Now, how many times can a quadratic cross the x-axis? If I move it up or down, either once or twice, right? Well, how many times can a square root cross the x-axis? Only ever once. How many answers did I get? 2. Okay, so we need to plug these both in and figure out if they both work. Is it possible that they both work? I mean, it'd be weird, but we did add 2 to it and it does equal x, so it is possible, but we need to make sure if they really both work. Okay, so if we substitute a 5 in, you don't have to write this down. You can do it in your head as long as you will do it. Okay, 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. 3 plus 2 is 5, and 5 equals 5. So that one does work. That one's fine. Okay, 1. Excuse me. 2 times 1 is 2 minus 1. 1. The square root of 1 is 1. 1 plus 2 is 3. 3 equals 1. It does not. Okay? Do you remember what that's called? Because I really want you to know the name of it. It's an extraneous solution. It's an extra solution that we got when we squared both sides, which we're allowed to do. But it gave us an extra solution that doesn't work. Okay? How do you feel about equations with radicals in them? Okay? Great. Awesome. Ooh. All right. Then let's move to solving equations with rational exponents. Okay? Rational exponents. So let's have 3x to the 3/4 power minus 6 equals 0. So what's our goal? Solve for x, right? In order to solve for x, we got to isolate it. Okay? What do you want to do first? First add 6. For the record, is that what you have to do first? You could, right? But that gets messy because you have to remember to divide every term, and so we try to do it in the order that's the easiest. Okay? So if I subtract 6 from both sides, I get 3x to the 3/4 equals 6. Now, my question to you now is, what is being raised to the 3/4 power? Only the x, right? What would have to be there for it to be the 3x that's being raised, the parentheses, right? Since the x is the only thing being raised to the 3/4 power, now what do I do to solve? I'm just going to divide by 3. We'll do that next. You see what I'm saying? We have to get rid of the 3 first because the 3 is not being raised to the 3/4 power. Only the x is. Okay? So now I have x to the 3/4 equals 2. And now we will raise both powers to the reciprocal of this power, like he was saying. Okay? So this is being raised to the 4/3, and this is being raised to the 4/3. I'm not multiplying 2 by 4/3. Are you clear with that? I'm raising 2 to the 4/3 power. Okay? So x equals, well, it's just x now because that's really 12 over 12, which is 1, right? 2 to the 3/4 power. So what's really happening? So remember, it's not times anything. It's raising to the power. The numerator is actually the power, and the denominator is actually what? The root. So you're going to have to figure out what the problem wants you to write as an answer. Because x equals 2 to the 4/3 power is a fine answer. I don't know if that's what the computer wants. Okay? So what's another option that we could put? Well, the cube root of 2 to the 4th power is fine. But I don't know if that's what the computer wants. So also the cube root of 16 is fine. And where did I get 16? 2 to the 4th, right? So that might just be a little game that you have to figure out what the computer wants. Yes? Uh-huh.
So I was able to like
Oh, okay.
get an actual.
So if this ended up being like 16 to the 4/3 power, how about 8 to the 4/3 power? We could actually take the cube root of 8, which would be 2, and then 2 to the 4th power, which would be just 16. But since 2 is not something that we can take the cube root of, that's when we have to mess with this. Does that make sense? Okay. How do you feel about rational exponents? Do you mind if I do one more example for you? Okay, of rational exponents? Okay. So let's do x to the 2/3 power minus 3/4 equals -1/2. So why would I do this problem for you? People freak out because there's fractions in it. So I need to ask you to not. Okay? So let's not freak out because of this. What do I do to solve it? Add 3/4 to both sides. So I have x to the 2/3 power equals 1/4. Are you positive about that? Good. I just want you to be positive, not questioning. Well, I guess I was questioning technically, but you know what I'm saying. So just in case, this is -2/4 plus 3/4. Now for the rest of you, are you okay with 1/4? Yes? Okay. So now what? Reciprocal. So raise both power to the 3/2. Raise both sides to the 3/2 power. This is a case where you can, right? So numerator is the power, the denominator is the root. So what is the square root of 1/2? Sorry, I was telling you the answer apparently. What is the square root of 1/4? 1/2. And what's 1/2 to the 3rd power? Let's write it. Hold on a second. So first we do 1/3 to the 1/2 power, which is 1/2. And then we raise that to the 3rd power. When we raise a fraction to a power, we raise the numerator to that power and the denominator to that power. Does that make sense? Now, the other thing that you have to think about here is not necessarily always easy because it doesn't look like what we're used to, is I just took the square root of 1/4, didn't I? Then I also have to keep that because I did a square root. Now, I didn't put the square root sign in there, but taking the 1/2 power is the square root. You remember that? Okay, so far? Okay. How do you feel about rational exponents? Oh, even better now? Awesome. So the next examples that we need to do are examples that are solving equations that are in quadratic in form. Quadratic in form. So they're not going to be x squared plus 3x plus 7, but they're going to be quadratic in form, more like x to the 4th equals 3x squared plus 7. You see what I'm saying? Okay. So, first of all, I want to do this example for you. X to the 4th minus 8x squared minus 9 equals 0. Okay? How could I solve this? So like complete the square? No, that's not what you're saying. You're saying move the 9 over and then just factor these two out. I don't really want to do that, just because since it's quadratic in form, I could actually try to factor it. Okay? Because it's quadratic in form, this is kind of like x squared and this is kind of like x, right? X squared and x, the numbers are half. Does that make sense? So I could try to factor it. I could say x squared minus 9 and x squared plus 1. But instead of putting x here, I put x squared because I know if I multiply those together, it has to be x to the 4th. Does that make sense? Because I said what multiplies to be negative 9 and adds to be negative 8, so I said that would be negative 9 and positive 1. Does that make sense? Okay, so then what I could do is set each one of them equal to 0. And I could add 9 to both sides here and get x squared equals 9. So when I take the square root of both sides, I get x equals plus or minus 3, right? And over here I could subtract 1 from both sides and get x squared equals negative 1. And when I square root both sides, then I get x equals plus or minus I. That's what I could do. That's not what this part of the book wants you to do. Okay? It wants you to do something new that you've never seen before. Okay? So I would like to show you how to do that, because it can actually come in very handy if you know how to do it, if you're not comfortable this way. Okay? And it's called a U substitution. Now, if you're in pre-cal, you might have seen it in pre-cal, and if you haven't seen it yet, you may shortly see it. Okay? So in a U substitution, you decide something is going to equal U. Okay? The letter U. I don't mean you personally, but the letter U. Okay? So in this case, we would decide that x squared equals U. Now, I don't expect you to know that off the top of your head, but I think you'll see why in just a minute. Okay? If I decide that x squared equals U, rewrite this equation for me. If x squared equals U, what does this term now become? U squared. Good. And you know how to solve that really easily, right? You know that U minus 9 and U plus 1 would equal 0. I'm sorry, my U looks a little V-ish. And so U equals 9 and U equals negative 1, right? Once you solved for U, then you have to go back to the beginning. What did I initially say U was equal to? X squared. So I have to replace the U with x squared. So now it's x squared equals 9 and x squared equals negative 1, and then I have to solve for x by square rooting both sides, which gives me x equals plus or minus 3, square rooting both sides, which gives me x equals plus or minus I. Do you see the difference? So if this was an x to the 9th and this was x to the 6th, what would we want our U to equal? Excuse me. How about x to the 8th and x to the 4th? Excuse me, I just said the wrong ones. I would want the U to equal x to the 4th, right? If this was x to the 10th and x to the 5th, what would I want U to equal? X to the 5th, right? So you just have to figure out what makes sense in the problem to make it actually be a quadratic and not just quadratic in form. So now do you see why I called this quadratic in form? Because it could be replaced with a U substitution to actually make it be a quadratic. But then you'd have to replace, once you solve for x, once you solve for U, you replace what you plugged in for U to begin with and then solve for x from there. Okay, that's called a U substitution. For the record, I did U substitution in my graduate work. And it was kind of cool. Mostly cool. Difficult, but fun. Okay? All right, so quadratic in form, now absolute value. Do you remember absolute value? What I hope you remember about absolute value is that I taught you how to do absolute value a little bit different that was in your textbook. Okay? And I'd like to remind you of that and even remind you of why we did it a little different. Okay? If we're just solving equations, it really doesn't matter. It's the inequalities where it matters. Okay? Because we said How many numbers can actually exist inside these absolute value bars to give you equal 5? Two different ones, right? Either a positive 5 or negative 5. So you have to take both of those into account by saying 2x minus 1 equals 5 or 2x minus 1 equals negative 5. And that's what your textbook said to do, and that's what we did not do. What we did was change the value of this to be one positive and one negative. And again, equations, it doesn't matter. Inequalities, it matters, because once you go dividing by negatives, you've got to be able to flip your inequality signs, and that's when it really mattered. But right now, we're only talking about equations, so I'm okay letting you make this number out here be a positive or a negative. Does that make sense? Do you remember us talking about that? Okay, so the only thing about it is you just have to solve the equation just two different times because of the fact that what's inside the absolute value can be a positive or a negative. Okay, so if we add 1 to both sides, we get 2x equals 6. Dividing both sides by 2 gives me x equals 3. On this one, I start again. Adding 1 to both sides gives me 2x equals negative 4. Dividing both sides by 2 gives me x equals negative 2. Now, which one of these is correct? Both of them are, right? Are you positive? We could check, right? So 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. Absolute value of negative 5 is 5. It's the same thing, right? So the other thing you need to be able to remember is that typically absolute value numbers are graphed. The part of their solution is the graph. Okay? So if 0 is here, and 1, 2, 3 is here, and negative 2 is right there, we have a dot on negative 2 and a dot on 3, and that's it. Okay? Sometimes, depending on how the numbers are, it might even look like this. Without all the little dashes on there. Okay? Any questions about that? Can I show you a tricky one before we're done? Okay. What about this one? Ever? There's not ever going to be a solution? If you take the absolute value, you're always going to get a distance from 0, which is going to be a positive number. So there's absolutely no work that needs to be done here. It's just no solution. Good job. The last thing on your objectives is asking about solve problems modeled by equations. And what does that usually mean? Word problems. Okay, so there's going to be word problems relating to factoring, relating to radical equations, relating to rational exponents, quadratic in form, and absolute value. So it's basically figuring out the numbers to write down and then solving them just like we just did in these examples back here. Okay? Do you have any questions? If you do, what could you do?